Hello, I'm an old guy and I do maths. Today we're looking at the division of a quartic, which is x to the power of 4, divided by a quadratic, x to the power of 2. And while you don't see this very often, problems like this do pop up from time to time. And I saw one recently and I thought this would be a good subject for a tutorial. So here we are. Okay, so here are two equations, and I just want to draw attention to this one first. We've got a power of 4, we've got a power of 2, a power of 1, and a constant. What we don't have is a power of 3 in here. So the very first thing that we're going to do is we're going to pop in a filler, 0x to the power of 3, so that every order in this operation is accounted for. Okay, let's go to work. Now, those of you who've seen my other videos on long division of polynomials will recognize my method. There's nothing different about what I do here compared to dividing, say, a cubic by a linear factor. There's just a little more work involved, that's all. Okay, so we're dividing by this expression, and so the first question we ask is, what do we have to do to this x squared to get x to the power of 4? And the answer is that we multiply it by x to the power of 2. And that gives us the following: x to the power of 4 plus 3x cubed. Now you see the importance of this filler, plus 4x squared. And as in previous examples, I simply subtract that, and what I am getting rid of is I'm getting rid of this first expression here. So, what does that get me? It gets me negative 3x cubed plus 3x squared, and I bring down the 9x. So all the time, because I'm dividing by a trinomial, I make sure that I have 3 expressions in here. Okay. What do I have to do to this to get this? So how do I transform x squared to negative 3x cubed? Well, I multiply it by negative 3x, and I get negative 3x squared minus 9x, negative 3x cubed, my mistake, minus 9x squared minus 12x, and subtract as before. These disappear. Positive 3x squared minus negative 9x squared gives me 12x squared. 9x squared minus negative 12x squared gives me 21x, that's positive, and I bring down the 3. Okay, next step. What do I have to do to this x squared to get 12x squared? Well, I multiply it by 12, positive 12, and I get 12x squared. 12 threes are 36 plus 36x. 12 fours are 48 plus 48, and I subtract all of this. That's a 3, believe it or not. I subtract all of this from this, and of course this disappears. 21 minus 36 gives me negative 15. 3 minus 48 gives me negative 45. There's an x in there too. So this expression minus this leaves me with negative 15x, 21 minus 36x, minus 45, 3 minus 40, 48. Okay. Now, the keen observers amongst you will notice that I could do the following. I could factorize this and write it as this. I don't know if there's any profit in that yet, because I've still got a little bit more work to do. Okay, so what we're looking for is we're looking for some sort of a result, something that we can write down to say that when you divide this by this, you get this expression. So what is this expression? Well, let's go to work. So the answer is x squared minus 3x plus 12, which we get from here, minus 15x minus 45 over x squared plus 3x plus 4. Now, I don't think there's any utility in using the factorized form of this, because there's nothing that we will be able to cancel here. We won't, if we factorize this, we probably won't get an expression that we can use to cancel. So this is our answer. Thank you very much for watching. I hope that was useful. See you next time.